Right, I went radically overboard just to see how far I could push the CRT I have, and I just needed a clearer image to be able to judge how well I repaired the vertical deflection. And it seems I did, but for that I had to connect the filament up to my variable power supply, and I'm feeding it now with 7.2 volts, and it's consuming about 620 milliamps right now instead of 600. So I'm pushing it by a full volt over its rated voltage just to see whether I get any better results. And well, I do get a result, and it is clearer, but not by very much. In fact, if I mess up the horizontal a bit, let me see. There you go. Well, you can see I've got nearly the full CRT covered with an image of sorts. Well, it's not really very clear or anything, but in any case it does show that I repaired the vertical deflection. Now that being said, the image is incredibly weak, very, very weak, and well, at this stage I can't tell really whether it's usable or not to repair the TV. I suppose it is. If I push the filament up, say, let's see if I push it up to 7.4. There. This is 7.4 volts I'm sending through the filament. Okay. So it is a bit brighter, but only a bit. Really, I can't really say it's a very clear image, but oh well. I suppose it's good enough for attempting a repair. Anyway, I do get, when I turn the tuner knob, I do seem to get a kind of a signal on the screen. You could say snow, I suppose, although let's face it, it's so weak, the image, that it's kind of hard to tell whether there is any snow at all on the image. Still, I suppose if I push the CRT hard enough, I can get some sort of image on it. So the next thing I'll do is well, I'll do two things. I'll fashion a very small variable power supply that I can set to a certain voltage within a tight range, let's say anywhere between 6 and 8 volts DC, and I will use that to feed a bit more power into the filament. In effect, you could say I will build a brightener but which I can set to any voltage I like, between, say, well, 5 and 8 volts or something like that. Just to be able to use this old CRT. And that way I might be able to repair the rest of the TV. Until I'm trying to inject a video signal into the TV. Now the sound is perfect. So the tuner is getting a signal, that's for sure. But I can't seem to make the picture lock. The horizontal seems to be completely out of whack. So I'm trying to find the sweet spot of the horizontal frequency. Well, this is about the sharpest I can get for the moment, and it's a checker pattern. If I push up the filament power just a little bit, this is about as bright as I can get it, which is, let's face it, not very bright. Now you can tell the picture is quite distorted at the moment, well, I still have quite a bit of work to do to to get the picture to improve a bit in sharpness and in contrast, although let's face it, with this picture tube it's quite unlikely I'll manage to get the picture really sharp or anything like that, but well, we can give it a try. So I will work a bit on the focusing magnets and see whether I can improve the picture a bit. Up to now, we can tell with quite a lot of certainty that the vertical and the horizontal circuitry of the high voltage part of the RCA is okay. So thanks to the fact that I replaced a lot of parts on the chassis, and I also repaired the vertical output part by replacing the bad transformer with a new one, I'm reasonably confident that the high voltage side of the TV chassis is okay now. Obviously it still needs quite a bit of tuning, let's say. The focus doesn't seem to work very well, but that may be due to the fact that the CRT is very weak, so I might have to look into that. The focusing is not very good, so despite the fact that the CRT is weak, the symmetry of the picture should be good. Now, the symmetry of the picture is partially influenced by the focusing magnets, which are in here, okay? And you'll remember they look like little flat gears about this wide, and there are two of them right here around the neck of the CRT, above the deflection coil assembly, yeah, above the yoke. So we need to align the picture, if you wish, with those focusing magnets. So that's what we still have to take care of. Also, the sound of the TV, which comes through this little speaker here, sounds a bit distorted to me. I'm not really happy with the sound it emits. So I might have to look into the amplification stage of the TV as well. Right, we also know that the tuner works. We pump in a signal, we get picture and sound. It might need an alignment though, because sound and video are not quite well synchronized, let's say, if that's the word for it. So either the sound is good and the video is bad, or the image is bad, or vice versa. The image is good and the sound is really very poor. We might have to look into that as well. Also, to my feeling at least, the contrast and the brightness control seem to have little or none or no effect on the image. Now, some could argue that has to do with the fact that the CRT is weak, but I believe that even with a weak CRT, the contrast and the brightness control should still have a visible effect, and they don't seem to have a visible effect on the image. So I really need to look into that as well. Now, frankly, I don't really like to work on the video side of the chassis right now, because whenever I need the picture to see whether I'm working in the right direction or not, I have to power the filament with a slightly higher voltage. Okay, so I'm pumping in about 7.5 volts into a filament which is meant to be used at 6.3 volts. So I'm pushing the filament quite hard to get a reasonable image. I don't like it, but for now that's the only way I can have a decent image to work with. I hope that by looking into the brightness and the contrast control, I can enhance the brightness of the CRT a bit more without pushing the voltage of the filament as hard as I'm doing now. Also, the high voltage is still a little bit low. So you'll remember last episode I showed you that the high voltage is at about 5 kilovolts. Now the schematic specifies that the voltage should be about 5.8 kilovolts. So it's about 800 volts low. I might have to look into that and see whether I can pump up the high voltage just a little bit. That too might influence the brightness and the quality of the picture. Also, I don't know if you noticed it last time, but when you look at the left side of the picture, so which on the CRT is this side here, then you will have noticed that the picture has a sort of a wavy pattern, being bright, dark, bright, dark, bright, dark. Now that effect, according to people who have been in the TV restoration business longer than I have, that would seem to suggest that effect, that the high voltage has poor filtering. So I might have to look into that as well and see whether I can improve the filtering on the high voltage, if of course that turns out to be the cause of the bad image. Also, although that's just a detail really, I need to turn the deflection coil a bit more, because the image is still skewed a bit, so diagonal actually, and I still need to move it a bit counterclockwise to make it truly horizontal. Well, there you are. That's where we're at right now. So let me have a look first at the brightness and the contrast control. I tried several times over and over with my pattern generator to improve the image, also with the focusing rings and with the contrast and the brightness, potentiometers. Well, I tried every trick in the book, so to speak, to improve the image. But I came to the conclusion that no matter how much I would tinker with all the settings, you know, for the horizontal sweep, the vertical sweep, the focusing magnets, you name it, I would not get a substantial improvement in the image quality. Okay, so okay, yes, right, we know that the tube is weak, and therefore the brightness, the overall brightness of the image is poor, to say the least. But really, aside from poor weakness, poor brightness, I should be able to get at least a good symmetry in the picture, a good geometry of the picture itself, which I don't seem to be able to attain or obtain by trimming everything. So I took another peek at the schematic. Well, you remember that I replaced the vertical output transformer. Okay, so this part here. Okay, now you also remember that I put a resistor in series with this coil. So actually right here at this point I put a resistor in series with the vertical deflection coil, and that resistor was one of 10 watts, 817 ohms. Now I did that for two reasons, namely that the transformer has in comparison to the original transformer, too low a resistance, and also because the voltage that comes out of the anode of this CG7 here, the 6CG7 vertical driver, yeah, is 440 volts, and the transformer is meant only to take 400. Now, you'll also remember that therefore I over-dimensioned, so to speak, the resistor a bit. So, in fact, the resistor is perhaps a bit too heavy on the circuit to heavy a load. And that is perhaps one of the reasons why the picture is distorted. Yes, is not really. I can't really get the picture to look geometrically pleasing. Okay, so there's not enough drive, as it were. And if you look at further down the circuit from the transformer, you see that the line goes down and right into the high voltage coil here, yeah, and on the other side right up into the horizontal sweep circuit. Now this could very well explain that if the drive signal which comes through here and goes down and down and then around into the horizontal sweep driver, yeah, if that signal is too weak, which comes down there, then we have a problem. Okay, that could affect not only the vertical deflection but the horizontal one as well. Okay, so what I think I'll do is, in fact, the resistor which I mounted here, I'll unclip it, or I'll clip the wire off of the resistor, and I'll tack temporarily a lighter resistor between this wire and this point, this tie point here. And I think I'll take a resistor of about 700 ohms. Okay, I admit it's a guesstimate on my part, but since I over-dimensioned the resistor by roughly 50 ohms, I think it wouldn't be a bad idea to try the other end of the spectrum, so to speak, and decrease it so that I can increase the signal strength which goes through the transformer and down eventually into the horizontal output driver. Okay, so let's start at that point. Well, and in fact, let's start by looking for a resistor which is close to 700 ohms and can take about 10 watts of power dissipation. Well, I think by reducing the resistance that I put between the transformer and the vertical drive tube did improve the quality of the image. However, with it, there has also been an increase of instability of the horizontal. Now, why that is, I need to find out. By playing a little bit with the drive, the horizontal drive, and the vertical deflection, I can stabilize the image, but only once in a while and never for very long. So let's say overall the quality of the image, at least when I can make it stand still, has improved. But now I need to contend with an increased instability. Now, strangely enough, reducing the resistance has also reduced the voltage between the vertical output transformer and the anode of the vertical drive tube. So in a sense it is a kind of improvement, since the image overall in symmetry has improved, but to the expense of stability. Now you can see right here there is a waviness to the left side of the picture right here, and I can't really explain for the moment why there is that kind of waviness, but like I said, overall the symmetry of the picture has improved. So I think I'm on the right path. Now the thing I need to do is to find a way to stabilize the picture. The symmetry of the image has improved a lot compared to what it was in the beginning. However, the stability is not very good, as you can tell for yourselves. So I'm kind of undecided whether the instability is due to a fault in the high voltage circuitry, or whether it has to do with the synchronization signal coming from the IF circuitry, or maybe a combination of both. Now, it comes and goes, which means that, you know, sometimes the image just jumps back to being normal, quote unquote, and then it returns to being a stripy pattern like you see right now. So overall, I would say reducing the resistance to the vertical deflection transformer has had a reasonably beneficial effect. But then again, the TV is now a bit more unstable. So I need to see whether I can still tweak the resistance a bit to increase stability, but yet to keep a reasonably symmetrical image. Okay, well, that's it for now. Well, I'll see you all back in the next episode.